Hello, everyone, and welcome to Bite-Sized Buhl. My name is Mike Hennessy. I'm an educator with the Buhl Planetarium at Carnegie Science Center, and we're looking at a digital representation of the night sky this evening. We're going to take a sneak peek at what you can see tonight or on the next clear night, and we're using Stellarium, which is a free software which you can download on your own phone or computer to do a little digital preparation for your stargazing at home. So welcome to the adventure. Let's see what's up there. As we look at the sky right now, imagine this is a clock. North is at the 12 o'clock position on your screen at the top of our star chart, and south is at the 6 o'clock position. We're going to be zooming in to the south-facing sky to get things started today. So we're looking at the horizon. On the south, we can see the sunset and just the glow of our sun in the sky in the southwest. And we see a train of planets followed by our own moon arcing through the sky. All of the planets, in fact, orbit the sun, the 8 major planets, in roughly the same plane. Our solar system looks something like a pancake. All of those planets basically formed out of an accretion disk of material around our young star, a pancake batter, if you will, and out of that primordial batter, the planets we have today are the blueberries that are left over. What that means for us here on Earth is that when we look up in the sky, we see the major planets all taking roughly the same arc, the same grand arc through our south-facing sky. And we refer to that as the ecliptic path. It's the path the sun takes through the day, and the major planets all move more or less along that ecliptic plane. Tonight, you can see 3 planets all trailing along behind the sun. If you're really savvy and fortunate, you might see Mercury, the closest planet to the sun. So if we can't ever spot Mercury, it's going to appear close to the sun, either at sunset or sunrise. Behind Mercury, we can see Saturn and Jupiter. That's just how they happen to align right now, like runners on different tracks, all going around our sun. That's where Jupiter and Saturn are in their paths. We're going to zoom in on these planets for a closer look. We can see that Jupiter is in the constellation of Aquarius. And what that means is, in a little bit, we'll darken the sky here, that Jupiter's passing in front of Aquarius from our perspective. The zodiac is in the same plane as the ecliptic, the paths that the planets take around the sun. Let's go ahead and zoom in on Jupiter for a closer look. Jupiter will be a fairly bright object that you can see with the naked eye. Through a telescope, we can see the bands of Jupiter. It is the largest planet in our solar system. Essentially a great big cosmic vacuum cleaner. Jupiter's immense gravitational pull sucks up comets and asteroids that could otherwise threaten life here on Earth. So it does a favor to the inner solar system by safeguarding life. Jupiter is sometimes referred to as a failed star. It's made of hydrogen and helium, just like our sun, although it never achieved nuclear fusion. And lots of ammonia compounds that give us those beautiful colors. Look at all the variation in those stripes there. Those are all storm systems swirling around Jupiter. It's essentially a ball of clouds and gas. To either side, you might see a little more greenish coloration. The greenish color you see off to the right here, that's one of the poles. That was more recently imaged by the Juno spacecraft, which is currently in orbit around Jupiter. If you have a telescope, see if you can spot Jupiter. But even more fun, place your phone or a camera on your telescope, take a picture of Jupiter, and send it in to NASA. Every once in a while, they'll pick their favorite photos, and that informs Juno, the satellite orbiting Jupiter. There's a citizen science camera on board, and your photo might actually tell Juno what to look at in the future. As we pull away, you can see a few bright specks right here around Jupiter. Those are the 4 Galilean moons. They were discovered by Galileo back in 1610 in January. Right about now, he was outside on a bell tower every night that it was clear for a month, watching these specks of light. And they were switching places. Sometimes one disappeared. He saw 3 of them moving. Eventually there was a 4th one. And Galileo realized that Jupiter has its own moons. That changed everything when we realized there was actual evidence that Earth isn't the center of everything, that other planets even have their own moons. I'm going to zoom in on just a couple of them to show you the contrast between them. This is my favorite. It's the moon of Io, fairly close to Jupiter, so that immense gravitational pull really wreaks havoc on this moon. It's incredibly volcanic. It almost looks like a piece of cheese pizza from space, right? Lots of sulfur compounds that have been emitted from volcanoes all over the surface of Io that create those white, yellow, and orange compounds. It's the sulfur compounds at different temperatures. In addition to volcanoes, there are lakes of lava. If you were standing on Io, for Pittsburghers, it might feel like you're on the pitfall at Kennywood, just going up and down. The immense tidal forces of the ground actually moving up and down, just from all the pulling and stretching from the proximity of Jupiter. We'll visit one more of the 4 moons that Galileo found for something very different. Our next stop is Europa. Europa is an icy ocean moon. So it's thought that there's a global ocean underneath this very reflective, crusty, icy exterior. And icy ocean moons of both Jupiter and Saturn are excellent candidates for the search for life in the solar system. Now, just south of Jupiter, setting sooner, will be Saturn. It's almost twice as far away. It's in the constellation of Capricornus. Let's take a look at Saturn. Saturn, like Jupiter, is almost a miniature solar system of moons around it, including the moon of Titan. There are tiny moons that actually orbit in the gaps of the rings that you see here. They help to shepherd debris, clean things up as they move around in the gaps of the rings, sort of creating little HOV lanes. They're just big enough with their gravity to push other stuff out of the way, or if it's very small, collect it to their own equatorial regions, and those moons move around in the gaps of the rings. We call them shepherd moons, as they shepherd material around. So here we have these beautiful rings. From this distance, they look like a solid phonograph or a golden record, but they're really billions of pieces of ice and rock. Saturn's rings are 175,000 miles wide. Imagine 20 Earths all lined up in a row, even 21 Earths. But if you got close enough, you'd see that Saturn's rings aren't solid at all. They're made of billions of pieces of rock, ice, dust. And Saturn has an icy ocean moon, which we'll zoom in on while we're here. This is Enceladus. Like Europa, it's an ice-encrusted, highly reflective body with a global ocean underneath. All right. And trailing Jupiter, Saturn, and Mercury in our south-facing sky, we have the moon. Well, as it turns out, the moon's orbit around the Earth is tilted only about 5 degrees with respect to the Earth's orbit around the sun. It's not that far off the ecliptic plane. So we see the moon taking a similar path through our sky as the planets. Tonight we have a nice waxing crescent moon. And in the week ahead, we'll start to see more and more of our moon being lit by the sun. But even from this perspective, with our crescent moon, we can see some of the variation there in the moon's composition. The whiter areas are rich in aluminum. We call those the lunar highlands. The darker spots you see there have formed different shapes and appearances for different cultures. Often it's interpreted as the man on the moon. But those darker spots are the result of ancient volcanic eruptions. That's volcanic rock from when the moon was young. All right. So we have this whole beautiful panoply of planets and our own moon to check out early in the evening sky. You can actually check out the time over here and change it in Stellarium. Right now, I've got it set for just around 6 o'clock this evening. But let's advance time and see what's in the winter sky in January a little later. We're going to head to around 10 p.m. here. This is military time up here, 24 hours. And as our sun has set, the planets and the moon are on their way below the horizon. The winter constellation Orion the Hunter has now taken center stage. Orion is a great place to start with your stargazing if you're facing south in the winter, because it can point the way to many other things. You can find Orion by locating the 3 stars that make up Orion's belt. From here, you can find the hot blue giant Rigel in Orion's knee, or head up to Orion's shoulder. It's a red giant known as Betelgeuse. And you can also use Orion to find lots of other constellations nearby. Let's draw a line together now from Orion's belt to the left. You'll come left and down, and you'll come to the brightest star in the evening sky. This is going to be the brightest thing other than the sun or the moon or Venus in the sky. This is the brightest distant star for us. That's Sirius, the dog star, and it anchors Canis Major, the big dog. Going from Orion's belt to Sirius, you can then head straight up to Procyon. That's Canis Minor, the little dog. You have to use a little imagination for that one. It's 2 stars and they make a line. But if you see a dog, more power to you. Coming back to Orion, we can use Orion's belt to find another famous constellation. We'll hang right off Orion's belt. We'll come to this red star right here, Aldebaran. Aldebaran is the eye of the bull, Taurus. And we found the zodiac. I'm going to zoom out again for a little perspective here. Again, we can see Orion facing south. Just behind Orion the Hunter, we have his hunting dogs, but we can use Orion to point the way to Taurus. Let's come back to Taurus now, the eye of the bull. The 3 stars in Orion's belt hang right to the red eye, and then catch the red eye to the Pleiades. You might see just behind the horns of the bull a small, it almost looks like a micro dipper, a miniature constellation in the night sky. It's known as the Pleiades, and we're going to zoom in on it. Now, to get a nice smooth zoom in Stellarium, you can go to a search window, and if you already know what object you're looking for, well, we can lock on and zoom on in for a closer look. All right, the Pleiades is my favorite thing to find in the winter sky. This is a star cluster. Some stars move through space solo, like our sun. Others are moving in a group. They're loosely bound together by gravity. And right now, this star cluster is moving through some interstellar dust and gas. These are a lot of blue stars that are causing the gas that they're passing through, the dust, to glow with this frosty blue haze. Perfect for stargazing in the winter. The Greeks, the ancient Greeks, referred to the Pleiades as the 7 sisters. They saw the 7 brightest stars that make up this micro dipper. In Japan, that's known as the Subaru. In fact, that's the inspiration for the Subaru car logo. All right, but we're going to head back to Orion for one more discovery in this neck of the woods. Let's come back to Orion's belt. Now you'll see we have lots of star clusters that have appeared here in Stellarium. But I'd like to take you to a nebula. Just below Orion's belt is the Orion Nebula. It's a fuzzy patch. It's visible to the naked eye. It's a lot farther away than the constellation Orion, but it's in the same direction, so it has the same name. We are now entering the Orion Nebula. Now the Pleiades are just passing through some gas and dust and making it glow a beautiful blue. This nebula, however, is a giant dust cloud where stars are being formed. It's a stellar nursery, and new stars are still being formed here today. When we have images of the Orion Nebula, the reddish color comes from hydrogen gas in that nebula. This is an amazing area for new star birth, which is still ongoing. All right, we're going to pull all the way out again. And we'll see if we can find one more thing to share with you today. Again, we're facing south right now. And I'm going to take us to a constellation that is high in the sky. Okay. All right. Over in the west, it's setting just behind the moon. I think I'm going to advance. I think I'm actually going to take time backwards a little bit here so we can get a better view. So here we are around 7 o'clock. If you head outside and you face south, you might see high in the sky a square. If you make a great big square, add a couple of legs to it, this is known as Pegasus, the flying horse. Now Pegasus actually shares a star and a story with an adjacent constellation. It's the constellation of Andromeda. The star that they share is known as Alpheratz. The story they share comes from ancient Greek mythology. Andromeda was chained to a rock, threatened by a nearby sea monster. Pegasus came to her rescue, and she flew to safety. Look for the great square of Pegasus and see if you can find the wishbone of Andromeda nearby, or perhaps a big letter A for Andromeda. If you look in that direction of the sky, you might see a fuzzy patch near Andromeda. And again, it's in the same direction as the constellation. It gets the same name. The Andromeda Galaxy is actually visible to the naked eye. I think it's amazing that if you head outside, give your eyes time to adapt in a dark sky, you can actually spot another galaxy. And so we'll end here today with the Andromeda Galaxy, home to hundreds of billions of stars. Look high in the sky this winter for the wishbone of Andromeda near the great square of Pegasus. Give your eyes some time to adapt and see if you can find Andromeda. If you see it, consider the light that we're seeing left that galaxy over 2 million years ago. Even moving at the speed of light, it took that long to reach our eyes. Andromeda is actually on a collision course with the Milky Way. Eventually, the two galaxies will merge in a nice, elegant dance of stars. They will form Milkdromeda, a new galaxy. Terrible name. If you have better names, feel free to leave them in the chat. We do have a few billion years to workshop that. But in the meantime, head outside and see if you can soak in the beauty of the Andromeda Galaxy the first time you have a clear night and a dark sky this winter. Well, we'll be back with a whole different topic next Thursday at 10:30 for another edition of Bite Size Buhl. We hope to see you then. In the meantime, wishing you clear skies. Keep looking up, folks.